All right, the next video here is going to deal with the arc length as a function. So instead of going from the lower and upper bounds of some interval, our lower bound is going to be determined as some value that you give. However, our upper bound is just going to be this t. So we're going to make a function out of out of the uh, out of the integral. And you've done something similar to this in different versions of calculus, where you evaluate from some 0 to x in your integral, and then you can fill in for x and see what you get. All right, so problem number 127, we're going to write out our value r as a parameter of s. So in this case, s is again the arc length, so we're going to write it as some sort of format of that. All right, so we're going to use the formula above. It's formula 314 is what we're going to use. And let's see. Well, first of all, r prime, the derivative of this 3 minus 3t is just minus 3, and the derivative of 4t is 4. So that's what our derivative is going to be. We can find a magnitude of that pretty easily as well. First component squared plus the second component squared. Is that, this is just 5. It's 25, and that's just 5. So what we know is that we have this value, this function s of t. This is going to equal 0 to t of that magnitude 5. And then we're going to take that integral. Well, the integral of 5 is just I guess it's not dt. We should probably make something else and just make du. So we'll get 5u evaluated from 0 to t. And we plug in the t and the 0. So this equals 5 times the quantity t minus 0, which is just 5t. Now, note that we have this s, function s is going to equal this 5t, which means t equals the arc length over 5. Thus, rt, I guess r of s, is for we're going to plug in wherever we see a t in our original function there. So we're using this r of t, so we're plugging in what we have there, I guess. Three minus 3s over 5, and the other one is just 4s over 5. And yeah, that should work.